Good morning, everybody. So just a quick announcement. Assignment 4 will appear later this weekend, probably tomorrow, I would think. The due date's probably going to move because I think it's too early. We're a little bit behind where we normally are in the course right now. So I'll just shift the assignment 4 due date a little bit and get the assignment to you this weekend. If you still haven't picked up your quiz yet, I'm going to put them outside my door at my office later this afternoon, and you can come pick them up whenever you want, as long as you can access the hallway that has where my office is. All right, so at the end of the last lecture, we were talking about creating additional constructors. And so in our point 2 class, where'd you go? Oh, in our point 2 class, we created a constructor that takes in an x and a y value. And this lets the user set or the caller set, create a point that has coordinates that they can set. Notice in this example, the parameters, the name of the parameters are the same as the name of our fields. So if we go back into Eclipse, right, we have fields x and y. Right? And now we have a constructor whose parameters are also named x and y. Right? It turns out this is very common in Java. It's especially for simple classes that represent some kind of value, right? It's often the case where your fields and the parameters of your methods, it's just easy to have them it's just convenient to have them have the same name. So in that case, you need some mechanism to disambiguate, does x mean the field x or does x mean the parameter x? Inside the method, x means the parameter x, right? So that x there is that x there. It's not the field x. The field x inside this constructor is this dot x. Right? And so in this particular case, you must use the keyword this to access the field. All right, so why do you want to do this sort of thing? It's because it makes your class easier to use for other people. Or if you're writing the class for yourself, it makes it easier for you to use. Right? So if you're making points, if you're using points, you probably want to make a point having some sort of specified coordinates. Right? Instead of making a point using the no argument constructor and then calling set, you can just call this constructor. Right? So in other words, instead of calling the no argument constructor and then using a method to set the coordinates, right, that lets you get rid of a line of code, and you can now just make the point with the coordinates that you want. And away you go. Right? All right, so for point 2, there really isn't any, well, that's not entirely true. I think that's the obvious constructor that you'd want to add, right? Using points, probably want to set the coordinates of the points, so provide a constructor that sets the coordinates of the point. There's another type of constructor that you might want to consider adding. Right? So there's something called the copy constructor. Now, the language specification, if you look at it, there's nothing that says copy constructor. So instead, the copy constructor is a technique that you can use to initialize an object by copying the state of another object. Right? That's why it's called a copy constructor. Right? You're copying some other object. So I would like to provide a constructor in point 2 that initializes the coordinates of the point by copying the coordinates of another point. Right? Now, when you create these kinds of constructors, typically, the constructor has one parameter. The type of the parameter is the same as the class, although later on in the course, you'll see that that is not exactly true. Right? So here's a copy constructor for our point 2 class. Right? It's a constructor, so its name is the same as the class. Right? It's going to copy this other point. Right? So we're going to initialize the state of the newly created point by copying the state of an existing point. Right? So in this constructor, the other point is called other. Right? And so whenever I make a copy constructor in this course, I'm always calling the thing other, right? To indicate to students that, hey, you want to copy this other point. Right? You can call this whatever you want. It doesn't have to be other. Right? So to copy the state of that point, I need to access the x and y coordinates of the other point. Right? Now notice that point 2, right, the thing that I'm copying is an instance of the class that I'm currently in. Right? So I'm copying another point 2 object. And that means I can access the x and y fields of other directly. Right? I'm inside the class. Right? Inside the class, I'm allowed to access the field directly. right? If I have a reference to a point2 object, then I can ask for its x coordinate directly by name. Similarly, I can ask for its y coordinate directly by name. Right? I want to set the coordinates of this point, so this dot x equals other x, and this dot y equals other y. Right? So in Eclipse, there's our copy constructor right there. Right? So again, right? You don't have to use this to access the fields x and y of the point that's being initialized. Right? There's no ambiguity as to what x you mean here. Right? There's no x in the parameter list. There's no local variable called x. Right? And so when you write x here, we mean the field x up here. Right? And when we write y here, right, we mean the field y here. Right?
Morning.
Good morning. Please don't interrupt me when I'm talking. So the coordinates of the other point are just other x and other y. Right? Now, whatever you do, right, don't flip the order of x and other x. Right? Right, don't do this. Oh, maybe not this. Don't do the following. Right? When you write other x equals x and other y equals y, you're changing the coordinates of the other point. That's not what you want to do, right? You want to initialize the state of this point, right? And so here, what ends up happening here is that other x gets set to 0 and other y gets set to 0. Right? The reason they get set to 0 is because if you use the names x and y before you set them, what ends up happening is you end up with the quote-unquote default field values, right? So for any numeric value, that's 0. Right? And so this doesn't give you an error, which it probably should. Instead, it sets other x and other y to 0 and 0. Right? You've now changed someone else's point, right? Which is probably very confusing to the person who just called your constructor. Right? So don't do that. Yes, question. Pardon me? No, the assignment is not there yet. I made an announcement at the beginning of class. It will show up later this weekend. Today? Later this weekend. Okay, so that is the correct way to write this constructor. All right, so again, why do you want to make this? Why do you want to add such a constructor? Because it lets people who are using your code, it lets people who are using the point2 class, it makes it easier to use the class. Right, so here's an example where you make a point, print the point, make another point that's supposed to be a copy of p. Right, so if you didn't have the constructor, you would have to write something like this. Right, so here's our point p. Right, let's set the point p to something, so 1.5 and 2.5. Right. If I didn't have a copy constructor and I wanted to copy the state of p, I would now have to write q.set px and py, like that. Right. Now, instead of having to write that, did I write that? Yeah, I can just write that. Right, and you now got a copy of the point p. Right, q and p are two distinct points. Right, they're two distinct objects, or they refer to two distinct objects. They happen to have the same coordinates. Right, but if you change p, the state of p, the state of q doesn't change. Oh, actually, that's what this slide is demonstrating here. Right, so here, q is a copy of p, and if you print out q, right, you see that p and q are both the same, or they both have the same coordinates. If you change p by calling a mutator method and then print out p, right, notice that the coordinates of p change to 99 and 44, but the coordinates of q remain unchanged. Right, so two distinct objects having their own state. All right, so if you've been paying attention, then you've been looking at the constructors, you'll realize that the constructors are basically doing all the constructors are basically doing the exact same thing. Right? So all three of our constructors, they have two lines of code. right? All three constructors set the x and y coordinate of the point to some value, right? And so what is happening here is that our constructors, they are all duplicating code, right? There's our no argument constructor. What does it do? It sets x and y, right? There's our two argument constructor. What does it do? It sets this x and this y, right? There's our copy constructor. What does it do? Well, it sets this x and this y. Right? So hopefully whoever taught you CISC121, they told you that, look, if you've got code that's duplicated, you shouldn't repeat that code over and over and over again. Right? Instead, you should write, well, in 121, you should write a function, right, and have the duplicated code go into the function. Right? So you can do the same thing in Java. Right? I can write a method, put the duplicated code into the method. Right? So I can make a method. I'm going to name it public for now, but later on I'm going to change that. Right? And so I want to create a method. Oh, wait, I have a method set. That will work for us. This works for us. Right? So instead of setting x and y to 0 and 0, I can just call set. Like that, right? Instead of setting this x and this y to x and y, I can call set x and y, right? And instead of setting this x and this y to other x and other y manually, I can call set, oh, sorry. So set other x, other y. That. Right? And I've now eliminated the duplicated lines, the lines of code that are more or less duplicating themselves. Right? In this particular example, you're not saving much work here. Right? You're not really saving yourself any work. It's not really a huge deal in this case that there were some duplicated lines of code. Right? I've replaced 2 lines of code with 1 in every instance. So you don't save a whole lot here. In these simple classes like point 2, often this doesn't really save you any work, and it doesn't really have any large advantages, right? But you can imagine a class that has many, many fields, right? And it also has many, many constructors. Instead of repeating all of that code over and over and over again, right, in all of your constructors, right, it's better to call a method or call another constructor, right? And so you can do this. Now that I've shown you this, right, there's a warning here. This is actually a bad idea in this case. Okay, so, and that I'm going to repeat 3 times because it turns out that this is really a bad idea. Okay, so in all 3 cases, you can do this. For this class, it'll work just fine. But in general, this turns out to be a very bad idea. The reason it turns out to be a bad idea, I can't explain to you until we've talked about inheritance in the course and how the mechanics of inheritance works in Java. The problem that's happening here is that you're calling a public method. So you're calling the method set. Where's set? You're calling the method set. Set's public. Furthermore, the set method is not final. I'll explain to you later in the course what a final method is, but right now it's not final. It turns out this will cause extremely hard to find, this has the potential to cause extremely hard to find bugs. So you don't want to do it this way, right? Although conceptually, this is what you want to do. Okay, so if you shouldn't do it this way, how should you do it instead? Right? Okay, so notice that our 2 argument constructor sets the coordinates of the point to 2 values that the user specifies. Right? So I would really like, if I wanted to do if I wanted to prevent code duplication, what I'd really like is to always call that 2 argument constructor. Right? So now the question becomes, can I call a constructor from within another constructor? The answer is yes, but you have to be very careful about how you do it. So there is a technique called constructor chaining. Okay? So a constructor is allowed to invoke another constructor. So inside a constructor, you may call another constructor for the same class. So inside a point2 constructor, I am allowed to call another point2 constructor. When you do this, it's called constructor chaining. Okay? If you choose to do this, right, notice there's a lot of rules that you have to remember. If you choose to do this, then it must occur on the first line. Right? So from within a constructor of point2, I may call another point2 constructor as long as I am on the first line of a constructor. Right? Okay, now how do you do this? Right? So the way you do this is, unfortunately, Java decided to recycle the this keyword. Right? And so I'm going to show you how you do this, and I'll explain what's going on. Whoa. Okay. So I'd like all three constructors to effectively call this constructor. Right? If you look at what set does exactly that. Right? Set sets this x and this y to some x and some y. Right? So that constructor is effectively the same as set. Right? So for this constructor to call this constructor, on the first line of the constructor, you write the word this. Then you call the constructor. So round bracket, right? So to set the coordinates of this point to 0, 0, I would like to call that constructor with the values 0 and 0. Right? For the copy constructor, right, I would like to call the second constructor, and I would like to pass in other x and other y. So on the first line of the copy constructor, you write this, round bracket, other x, other y. Right? That calls that constructor here. This constructor does whatever it needs to do, and then it returns back to the line after that line there. Right? So if the copy constructor has to do some additional work, you can do additional work right there. Right? And so that's how you use the technique called constructor chaining. Right? Again, in this case, it doesn't save you a whole lot of work. Right? Saves you exactly one line of code here and one line of code here. Right? If you have if you have more fields, right, or if your constructor logic is very complicated, this technique can save you a lot of work. Right? You write the constructor once, and then you simply reuse the constructor that you've written to implement the other constructors. Right? Okay, anybody have any questions about that? This often causes confusion. Yes?
So, this keyword,
yeah.
is it searching for one constructor but not using this to search for another constructor?
So based on the so based on the context of which this is occurring, right? So this is occurring on the first line of the constructor, right? It's the word this followed by round brackets, right? The Java compiler can infer that you're trying to call another constructor, right? And so now it searches the other constructors for a constructor that has a double and a double parameter, right? And so it finds this one here, because there's only 3, right? So it's not that one, because that one takes in another point, right? So it finds this one, right? And it infers, oh, they're trying to call this constructor here, right? So that leads to this constructor running. When it finishes running it, it comes back up to here. And then if you have to add additional code here, you can. Yes. So that's exactly what's happening, right? I'm not crazy that they reused the this keyword here. So now this means something else, right? But that's the way they chose to write. That's the way they chose to implement this in the language, right? So if you're going to use constructor chaining, it's this to call the constructor, right? Not point 2, right? So you don't write point 2, 0, 0. It's always this 0, 0. Right? Okay. Any other questions about this particular slide? All right. Now we got a few other we were looking at a couple of other classes, so we can do the same exercise in all these other classes. Right? We've got this counter class, right? The counter class, its no argument constructor sets the value of the counter to 0, right? You might want to set the value of the counter to some positive, so to some non-zero positive value, right? You might want to copy another counter. Right? So we can provide 2 more constructors in the counter class, right? At the same time, we can use constructor chaining to minimize any code duplication. Right? So inside the counter class, I'm going to change the no argument constructor. Right? Before we had this value equals 0. So now I'm going to make a second constructor where you pass in the value. Right? So we're going to pass in the value 0 for the no argument constructor. Right? Now, the constructor that sets the value to a specified value has to do some extra work. Right? So remember, our counter class has a promise associated with it. Right? It says the value of the counter shall always be 0 or positive. So if you provide a constructor where the caller can provide an arbitrary value, right, it is the responsibility of the constructor to ensure that this value is legal. Right? In other words, it satisfies the constraints of the counter class. Right? And so this constructor initializes this counter to the specified non-negative value. Right? So the very first thing you need to do in this particular constructor is make sure that value is legal. Right? If it's not legal for the counter class, right? So in other words, if the value is less than 0, right, it would be nice to indicate to the caller that they've done something wrong. Right? So here, the way you indicate to the caller that they've done something wrong in Java is throw an exception. Right? Illegal argument exception, that's the standard exception you throw if an argument to the constructor or method is not valid. Right? So here we throw a new illegal argument exception. You can provide a message if you want, right? And then at this point, right, where you throw the exception, the constructor stops running. Right? And so this constructor fails to correctly initialize or does not stops. So this constructor does not create a correctly initialized object, right? Which is exactly what you want, right? If someone passes in an illegal value, there's no way for this constructor to do its work. Well, that's not true. If someone passes in an illegal value, right, we can indicate to the caller that this is an illegal value, right? If the value is legal, we can just go ahead and set the value equal to value. Right? Next, the copy constructor. Right? This constructor copies the state of the other counter. Right? So I can just call that previous constructor, passing in the value of the other counter. Right? So again, this round bracket, other value, calls that constructor there. Right? This constructor runs, sets value to value, right? And then program flow ends up here. Right? If this constructor needs to do additional work, you can do the additional work at this point. Okay, so now notice the disadvantage of constructor chaining here. Right? The no argument constructor sets its value to 0. 0 is a valid value for a counter. There is no reason to have to validate whether or not 0 is legal. If you use constructor chaining, though, you end up paying the price of the validation. Right? So when you use constructor chaining, there's no way for this constructor to know that the incoming value is legal. Right? So it always has to check. Right? In this constructor, you know for sure that 0 is legal. So you would like to initialize the counter without paying for that if statement. Right? And the same is true here. Right? Assuming your class is implemented correctly, the value of the other counter is supposed to be positive or 0. So you know that other value is legal. Right? You should not have to validate the value of other value. If you use constructor chaining, you pay the price of that validation every time. Right? And so there are disadvantages to this technique as well. All right, any questions on constructors or constructor chaining? Super. Okay, so we're now in to the deck of slides called classes 2, which we've seen a little bit. So this is the deck of slides 13. Now, we've seen part of it already. So this is the set of slides that talks about JavaDoc. So I'm just going to skip over all of that because I talked about that in a previous lecture. I guess I will say one note regarding JavaDoc. If you plan on going into, if you plan on a career where you end up writing code professionally in Java, right, you really do need to learn how to write easy to read, informative documentation, right? That's not really one of the learning outcomes in this course, right? For the purposes of this course, I'm happy that you know the mechanics of using JavaDoc, right? I'm not really interested in whether or not you can write, good documentation, right? Hopefully, in your other courses, there will be time to talk about how to do that. There is a fairly involved document here that talks about, that gives you the best practices for writing Java documentation and documentation in general, right? Writing documentation is an important part of professional software development, right? You really ought to, at some point, learn how to do this. Okay. So that counter example I showed you is an example of a constructor that has what's called a precondition. Right? And so there are these things called preconditions and postconditions that constructors and methods can have. Right? These are not Java concepts. These are software engineering concepts. Right? So some methods and or constructors, they require that one or more conditions be true after the method or constructor is finished running. Right? So for example, if you have a point and you would like to divide the coordinates of the point by some number, right, using this method called divide, right, then it's pretty important that when you divide the coordinates of the point by the value s, right, that s is not 0, right, because now you end up with a division by 0 error. Right? And so a method or constructor precondition is a condition, so something that's true or false, right, that the caller of the method or constructor must ensure is true before they call that method or constructor. Right? So in other words, if you call the constructor or method and there are some conditions on the inputs to that constructor or method, then it's the responsibility of the caller to satisfy those conditions. Right? So it's the caller that's responsible for this. Right? So if you have a constructor or method that does have a precondition, right, then that precondition should be documented in the documentation for the method or constructor. Right? Now, JavaDoc doesn't have a special tag for this. Right? And so what you end up doing is you end up documenting that condition somewhere in the description of the method, or if your method throws an exception, you can document it in the exception part. Okay, so here's the divide method for point 2. Right? So the method divide takes a point, right? The method divide, when you call it on a point, takes the coordinates of the point and divides it by s. Right? So divides this point by the scalar value, changing the coordinates of this point. So all I'm going to do is write this dot x divided by s and this dot y divided by s. Right? In the parameter section, there's a condition on this value of s. Right? So here in the description, you can write something like, the scalar value to divide this point by, semicolon, must not be equal to 0. Right? Up here, you could write the value of s must not be equal to 0, or something like that. Right? So you have to document the fact that there are some conditions on this value s. Right? Otherwise, there's no way for the divide method to properly do the work that it needs to do. Right? Okay, so look. The responsibility of meeting a precondition lies with the caller of the method or constructor, right? So it's the person that's using the method. They're the one that's responsible for making sure that they pass in correct values, right? And so that means that you, as the person that is implementing the method or constructor, right, you can do whatever you want if the precondition is not satisfied, right? So for example, you can simply go ahead and divide this x by s and this y by s, right? And then reassign the values back to this x and this y, right? So yes, there's a problem if s is 0, but you've told everybody, hey, it's up to you to make sure that the value of s is not 0, right? So this is one way that you could write this method, right? As the person that's implementing the method, you've satisfied your requirement to tell the caller that they must not pass in an illegal value, right? Okay, so the problem is, so basically we're going to assume that the precondition is true, right? So when we implement the method, assume the precondition is true, go ahead, implement the method the way you would normally implement it. Now, the problem with doing this is that the method will run with an input that is invalid or illegal, right? And so what can happen, right? If your method returns a value, it now might return the wrong value, right? The method might encounter an error, right? Sorry? Slide 36 in lecture deck 13. 13. Okay, so you might encounter some kind of error, right? When you encounter an error in Java, it's possible that the method, the error causes an exception to be thrown, right? Notice that the documentation for divide does not say that it throws an exception, right? So if dividing by 0 happens to throw an exception, right, this method doesn't tell you that that exception might happen, right? And so now something unexpected happens, right? Turns out dividing by 0 never causes an exception in Java. Dividing a floating point value by 0 never causes an exception. Right? So that's not going to happen in this case, right? What else might happen? Well, the method just ran with invalid inputs, so it's probably the case that the method can't do everything that it promises to do, right? And so we say that the method does not satisfy its postconditions, which we'll talk about shortly, right? Finally, the method might run to completion, but if it does, there's the possibility that it ends up putting the object into an invalid state. So if you call divide on a point, what you end up with is a point whose coordinates are infinity and infinity, positive or negative depending on the sign of x and y, right? And so now you end up with a point whose coordinates are plus and minus positive infinity, right? Which for the user of the point class might be unusual, right? So generally you don't want to ignore a failed precondition, right, as the implementer of a method, right? So here's an example here. I make a point 1, 2, divide the coordinates of the point by 0. It works in this case, right? Print the point, you end up with infinity and infinity, right? Depending on how you've decided to implement this point2 class, this might be an acceptable result. Okay, so instead of ignoring preconditions, or instead of ignoring failed preconditions, right? It's generally the practice in Java that you check or validate the input argument's values. Right? If you find an argument value that is not valid, then you should throw an exception. Right? And you actually saw this on assignment 1 and 2. Right? Many of the methods that you were asked to implement actually check the input values to determine, they check the input indexes to determine if they're valid indexes. Right? If they weren't, then you were supposed to throw some kind of exception. Why is this here? I'm just going to quickly check what's going on. It looks like I talked a little bit more about exceptions here. Okay, so we've talked about exceptions a little bit in the course before, right? In Java and in Python, and in many other modern programming languages, there are these things called exceptions, right? This is just short for exceptional event. This is a quote from the Java tutorials on exceptions, which you can read by following that link there. Right? So when an error occurs within a method or constructor, the method creates an object and hands it off to the runtime system, right? So exceptions in Java are just objects, right? So you make an exception object, And then you now need to indicate to the Java virtual machine that an exception has occurred, right? And so the mechanism in Java is to throw the exception, right? So creating an exception object and handing it to the runtime system is called throwing an exception. Right? It turns out there's many, many, many kinds of exceptions that you can throw, right? And you can make your own exceptions, right? So in assignment 1, I made an exception class for you to use, right? And you would throw forest fire exception or something like that, Right? The common ones that you will see, I guess the most common ones that you'll encounter, is this thing called illegal argument exception, right? That's the exception that's typically thrown when a precondition is not met, right? You'll see index out of bounds exception if you are using some kind of indexed data structure, like a string or list, and the index is invalid, right? You'll also see this thing called null pointer exception. So I haven't talked much about this, about the value null, and I guess this is a good time to do it. I'm going to leave this for now. I'm not going to change that to constructor chaining. Instead, I'm going to go down here and do something. Okay, so I'm going to make a point2 variable. Q, I guess we're on R. Okay, so in Java, there's this keyword called null, little n, null, right? You can use null for any reference. You can assign null to any reference variable, right? Null in Java means no object, right? So R refers to no object, right? Now, if I don't actually have a point2 object, right, then I can't safely use R to call a method. You cannot use R to safely call a point2 method, right? So for example, R set. Oh no, let's do this. Double x equals r dot x. So I want to get the x coordinate of the point, right? If I run that, whoop, there you go, right? It runs up to line 76, and then on line 76, that causes what's called a null pointer exception, right? So if you ever see this null pointer exception, this is what's happening, right? You've used a reference that happens to be null, right? Refers to no object, right? It causes a null pointer exception here because what does x do? X returns the coordinates of this point. R refers to no point. So there is no x coordinate for that point, right? And so in Java, what happens is you end up with a null pointer exception, right? Your program stops running at that point right there. Okay, so null only applies to references, right? You cannot assign null to a primitive type, right? So int z equals null. That does not work, right? Notice that it's in red. If you hover over it, it says type mismatch cannot convert from null to int, right? So you cannot use the value null with primitive values, right? Which occasionally students will try to do something like this, right? They'll be writing some piece of code, they'll create a variable, and they don't know what to initialize the variable to, right? And so if you have a primitive type, it's you should always initialize that that value to something, right? Now, if you don't know what to initialize it to, you still have to pick some value. You cannot pick null, right? So that's not allowed. So that doesn't work. Right? But if you have a reference and you don't know what to initialize that reference to, you can use null. Right? You just have to be careful, right, that you don't use the reference to call a method while the value is null. Right? So in other words, at some point before I call r.x, I have to assign a valid point2 object to r. Right? And so that's where, that's what null means in Java. Right? Right? And that's where the null pointer exception comes from. Okay, so when you throw an exception, right, or to throw an exception, you use the keyword throws followed by a reference to an exception object. Right? When you throw that exception, that causes the method to immediately stop running, right, wherever the throws statement was. Right? So any code in the method after throws never runs. Right? So back here in our constructor, but not this constructor, sorry. Let's put in the, oh, I'm going to put in a divide here. So public point 2. Okay, so here I'm actually going to validate the value of s. Right, so if s is a 0, yep, if s, that's fine. Throw new. Like that. You can put in a message if you want. I'm not going to put one in because I'm feeling lazy. Right? Otherwise, this dot x divide equals x. Sorry, s. This dot. Okay, so divide equals in Java means take the value on the left-hand side, divide it by the value on the right-hand side, assign it back to the value on the left-hand side. So that's just a short form of writing this dot x equals this dot x. Right. There's a multiplies equals, there's a plus equals, there's a minus equals as well. Okay, so in this piece of code here, right, on that line, assuming that line runs, right, that method stops running right there. Right? In other words, the coordinates of the point are never divided by s. Right? A common error that's made is that newer programmers will write that. Right? So they'll go ahead and do the work that they're supposed to do. So they'll divide the coordinates of the point by s. Right? And then at the end, they'll check. Right? Oh, was s valid or not? Right? Oh, it's not valid. I should throw an exception. Right? What's the problem with this? You've divided the coordinates of the point by an invalid value, right? And so now you have an object whose state is invalid, right? Its coordinates are infinity and infinity. So you want to validate first, throw an exception if you have to, and then do whatever work was legal to do to begin with, right? So don't write that, right? Validate first, right? Only if the validation succeeds should you actually change the state of the object. And hopefully that message will go away now. Oh, point 2, sorry, point 2, there we go. Like that. Right, and so that means you should always check the arguments first, throw an exception if required before changing the state of the object. Right, and so there's the better version of divide. Okay, so that's a precondition. Do we have time for this? Sorry. Oh. 9, yeah, we do, okay. Okay, so that's a precondition, right? So a precondition, condition on the inputs of the method or constructor, right? The caller of the method constructor is responsible for ensuring that the preconditions are satisfied. There's something called the postcondition, right? The postcondition is a condition that the method or constructor must ensure is true immediately before it stops running, right? So right after the last line of code in the method or constructor, your postconditions must be true, right? Now, the responsibility for meeting the postcondition, that lies with whoever wrote the method, right? So it's the method or constructor that's responsible for ensuring that the postconditions are satisfied, right? And so preconditions plus postconditions in the object-oriented programming world, these are often referred to as the contracts of the method, right? So in analogy with a contract in real life, right? So the contract of a method is the method promises to do something, right? That's its postconditions. As long as whoever called the method satisfied some conditions themselves. Those are the preconditions, right? If your postcondition is not true after your method finishes running, then you've done something wrong, right? There's something flawed with the method, right? So what can postconditions be? It turns out they can be lots of things, right? So postconditions always, technically it's always supposed to be a condition, something that's true or false. You'll very quickly realize that phrasing a postcondition as something that's always true or false becomes very inconvenient, right? I don't think we'll see an example today. It'll be next week. Okay, so what postconditions might a method have, right? So if the method returns a value, right, it's probably promising something about the returned value, right? So for example, the square root of a number should be equal to the square root of a number, right? There could be some conditions on the fields of the object, right? So if a method changes the state of an object, right, then it might promise to change the state in a particular way, right? So the set method promises to change the x and y coordinates of the point to the specified x and y values, right? A non-static method is also allowed, well, any method in Java can change the state of one of its arguments as long as the argument is a reference. Right? So for example, if you have a method that takes a point2 object, right, that method might promise to change the state of the point2 object in some way. So in Java, your postconditions, they're normally described in the documentation of the method in a few places, right? So here we have the method x, right? This method promises to return the x coordinate of this point, right? That's its postcondition. Right? If your method returns a value, right, the postcondition is typically documented in the @return tag, right? So there's, that's the postcondition. Now notice this postcondition is not something that's true or false, right? So again, expressing the postcondition as something that's strictly true or false is really awkward, right? In the next lecture, I'm going to show you what that looks like if you try to express it as a true or false condition, right? Instead, it's much easier to express it in plain English. Oh, here it is right here. I'm going to stop here because I don't want to get into this, right? We'll get into this in the next lecture. So that's it for this week. We'll see you, I guess, on Monday.